Okay, in lesson 3, we're going to continue with interpreting fraction as a division. And today we're just going to take a look at the different forms of it and see how we can use the different forms to apply it to unit form, to apply it to improper fractions, to apply it to standard algorithm. Okay, in lesson 3, we're still going along with the same theme that we figured out in lesson 2, that if you rewrite a division problem as a fraction, it gives you your answer. We're just going to look at some different forms today, and we're going to see how we could use that form to help us fill out possibly missing data in other forms. Now, some interrelationships we can see between them, just like we had in the last one. We can see 4 divided by 3 right here, and we know that from that we can actually create the improper fraction of 4/3. And then 4/3, we know we can go ahead and 3 will go into 4 one time, and leaving 1 left over gives you the mixed number. Now, where some students get confused is when it comes to unit form. And here they're saying, okay, well, we know 4 divided by 3, okay. Well, if you take 4 times 3, that's 12. So 12/3, because we're in thirds here, 12/3 divided by 3 would equal 4/3. And that's exactly what we have here. Now, the way it looks in the standard algorithm, and this is one thing students have to watch for, is because when they write it in the standard algorithm, because it's 4 divided by 3, 4 is your dividend. It has to go inside the bracket. Okay, your 3 is your divisor, the one that's dividing over here, and that means it has to go on the outside. Students have a tendency to put that 4 on the outside and the 3 on the inside all the time. Now, the way it looks, we can see 3 goes into 4 one time. 1 times 3 is 3, and they subtract it, and they got 1 left over. And they rewrote that as a remainder of 1 over their divisor, which is 3, so 1/3, so 1 1/3. Now, in order to check your answer, we always take our divisor times our quotient, which is the answer to the division problem, and add in the remainder. Well, in this case, the remainder is in our answer. Okay. So if we could do it 2 ways. One, we can go 3 times 1 is 3, plus your remainder on the bottom 1 is 4. Well, let's do the check with the mixed number. Now, you know 3 times 1 1/3 is just adding 1 1/3 3 times. So 1 plus 1 plus 1 gives us 3. Then we have 1/3 plus 1/3 plus 1/3 gives us 3/3. 3 plus 1 whole gives us 4, and it checks. All right. Now, we have a mixed number this time, and we know to turn it into an improper fraction. This here is actually this whole number. Since it's in fifths, I'm going to take that whole number 1, and I'll put it 5 over 5, because that's still equal to 1, plus 2/5, which will give me 7/5. Now, since we have this, I know I can take and move this over to here. I know 7 divided by 5. Now, I know 7 times 5 is 35, so I know 35/5 divided by 5 equals 7/5. Now, over here in the standard form, I'm going to give my standard little arc there, or angle, and it's 7 divided by 5. So I know I'm dividing 7, so I'm putting 7 aside, and I'm dividing by 5. 5 will go into 7 one time. 1 times 5 is 5. Subtract that, and we see we have a remainder of 2. Rewriting the remainder as a fraction, we have 2/5. So we have 1 2/5. So to check this, we would multiply our divisor times 1 2/5, which is 1 2/5 added 5 times. 1 2/5 plus 1 2/5 plus 1 2/5 plus 1 2/5 plus 1 2/5. So adding up our holes, I got 1, 2, 3, 4, 5 holes. I have 2/5, 4/5, 6/5, 8/5, 10/5. Now 10/5 is actually equal to 5 will go into 10 two times, so we end up with 7, which checks because that's what we started out with. Okay, this time we were given the division expression and we were given the improper fraction. So to find the mixed number, we know we can take the denominator, 4 divided into 7, will go 1 time and there's 3 left over, so we got 3/4. Now for our unit form, we're knowing fourths, so I'm going to go 7 times 4 is 28, so I can say 28/4 divided by 4 is equal to 7/4. Now our standard algorithm, we know it's 7 divided by 4. 4 going to 7 one time. 1 times 4 is 4. And we have a remainder of 3. And it becomes 3/4. Now we have 4 times 1/3, so we know we have 4 times 1 3/4 to check our answer. So that means we can add 1 3/4 4 times. So our whole numbers, we can see we have 1, 2, 3, 4 whole numbers. Now I'm going to count how many fourths I have. 3, 6, 9, 12. And I know 4 plus 12/4, 4 will go into 12 3 times. Okay, so now let's take this into a word problem and see what we can apply. It says, if there are 15 liters of milk in the refrigerator, after how many days will more milk be needed to be purchased? Okay, well, it says there's 4 liters of milk. And it says that if there are 15 liters of milk in the refrigerator, after how many days will more milk be needed? Okay, so let's see how long the 4 liters will last. Okay, because it takes 4 liters of milk every day, 15 liters. So we know we're saying 15 liters divided by 4, because it's 4 liters per day, which we know that would be equal to 15/4, which we can convert that into a mixed number because 4 will go into 15 3 times. That'd be 12, and there'd be 3 left over, so 3/4. So we can say that that we know now, and I'm going to do a little diagram to make sure. We know that this here, the total, is how long it will last, total days. And it says this one will last 3 3/4 days. So after how many days will more milk be needed? Now, if they wait till the 4th day, there's going to be half a day during that 4th day that they don't have any milk. So they're going to they will need to purchase more milk after 3 days because there will not be enough milk for day 4. Okay, and B, if only half as much milk is used each day, after how many days will more milk need to be purchased? We'll say they're a half amount. Are they still saying that you have 15 liters? But now instead of using 4 per day, we're going to use 2 because it said half of it. So it's going to be 2 liters, which equals 15 seconds, which equals 2 will go into 15 7 times, so it's 1.5. So once again, we can see that it will last 7.5 days. So on this one here, they would need to purchase more milk on the 7th day because there would not be enough for day 7, period. Run out of room for my sentence. Number 3, Polly buys 14 cupcakes for a party. The bakery puts them in boxes that hold 4 cupcakes each. How many boxes will be needed for Polly to bring all the cupcakes to the party? Explain how you know. Now you got to read these very carefully. Okay? So some of the important information here. Polly buys 14 cupcakes, so that's important. The baker puts them in boxes that hold 4 each. How many boxes will be needed for the Polly to bring all the cupcakes? Okay, so you can see what they did. They took 14 cupcakes and they divided it by 4 because 4 per box, and it says that they would need 3 2/4 boxes, which is equivalent to 3.5. Okay, and they show the standard algorithm over here how they solved it. They said 14/4, so 14 divided by 4, 4 going to 14 3 times, 3 times 4 is 12, subtract that 2, we got 2/4. Now, if you look at their explanation down there, it will take 4 boxes. So if you put the answer of 3.5 down and left that as your answer, you would be wrong. Because that's where this key right here said all. Because in order to get all the cupcakes, because you still had half a box, you would have, even though you're not going to fill it, you would have to get that extra box to take all the cupcakes. So the correct answer would have been 4 boxes. Okay. If the bakery completely fills as many boxes as possible, what fraction of the last box is empty? How many more cupcakes are needed to fill the box? Well, we can see from work we've already done up here, there were 3.5 boxes filled, so 1/2 box was empty. Now, in order to need how many they need, here I have a box. It said there were 4 cupcakes per, half of it was full, and here's 2 that were missing. So we can see by this they would need 2 cupcakes to fill last box.